Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 4 of a unit Laws of Motion. So let's begin with today's class. In today's class we are going to discuss about the rocket propulsion and variable mass system. So let's first begin with the rocket propulsion and then we will switch to the variable mass system. So what is rocket propulsion and how does it work? We can say that rocket propulsion is based on the law of conservation of linear momentum. Even we can say it is based on the Newton's third law of motion. Yes, what we know, it's a rocket is a system in which mass varies with the time. So let's suppose the situation is something like this. I hope you have seen the rocket. You have seen the rocket, and you might have seen the launching of the any space shuttle. So the situation is one system let's say is there, and another is the fuel tank would be there, and from the fuel tank a fuel is going to be burnt, and the exhaust gas whatever that are leaving the system, it provides an required force so that this rocket can go in the upward direction. So this can be considered as a variable mass system, and that's why we can say its mass varies with the time. Let's suppose u naught be the initial velocity of the rocket, and initial mass of the system would be m naught with it fuels at any time. Now let's define certain term. It's a rate of mass of gases that is ejected, that is R can be considered as dm by dt. Mass at any time t, because it is decreasing at every instant. So that can be written as m is equals to m naught. I have said that m naught was the initial mass minus of dm by dt into t. So if I required to find out the acceleration, what I know, it's an a is equals to u by m multiplied by dm by dt. The dm by dt, it is a rate of mass of gas that has been ejected. Now let's suppose the situation is u naught is the initial velocity of the rocket and u is the velocity of the ejected gas. Then the velocity of the rocket at any time t, what I can understood is v is equals to u naught plus u log m naught by m to the base e, where m naught is the mass of the rocket at any instant of time t, and last, it's a thrust on the rocket can be calculated as F is equals to ma. A could be written as dv by dt, but here the things would be the different. How it would be a different? It would be a different that my velocity would be the constant and mass remains the change. It is the mass which is variable. That's why it is called as a variable mass system. So this is R into U. Acceleration, if I require acceleration, I have been with the force, then acceleration can be written as F divided by M. And let's just replace the value. The value of the F was the U into dm by dt divided by M. This could be written as R into U by M. Yes, R is the rate of masses of gas that has been ejected. The final velocity could be written as U log of m naught by m to the base e. So this is the system which is being used for the variable masses, and this is the special case for the rocket propulsion. Now let's look what the general case is and how it be used. What we understand is that F is equals to dp by dt, and in normal situation the things would be that is m into divided by dt. This is the normal situation where mass remains the constant and velocity would be changing, and in this situation we can just write it as F is equals to ma. This is the cases of approximately 90-95% practical applications. But there are certain applications where the things will be totally different, such as that this is F is equals to dp by dt, where velocity would remain the constant, and it is the mass that is changing. So this is can be written as F is equals to V multiplied by dm by dt. This is the variable mass system. If I required then acceleration, what I can write, it's an m into a, that should be is equals to v dm by dt. It's an acceleration which could be written as v dm by dt divided by mass m. Now let's suppose I have been asked that what would be the acceleration of the system after certain time. What I can have, it's an a is equals to v dm by dt divided by m naught, which will be the initial mass, minus of dm by dt into t. Yes, this is the rate of ejection of fuel. And in this situation, my system, that means my rocket, is moving in the upward direction while gases are leaving behind. So if I consider the effect of gravity, then I can write like this, it's a v dm by dt divided by m naught minus of dm by dt multiplied by t minus of g. So this is with the effect of gravity. This is the complete relation of acceleration of this kind of system after any instant t. I hope these things are clear. Is it clear? Any doubts? Any confusion? No? Then are you ready for the question? Are you? Great. Let's have a look then. What does it say? It says a 5000 kg rocket is set for vertical firing. The exhaust speed is 800 meter per second. So U is given 800 meter per second and mass of an rocket is given. That is the M is equals to 5000 kg. To give an upward acceleration of 20 meter per second square, the amount of gas ejected per second, that's why dm by dt is our requirement per second to supply the needed thrust. Yes, what we understand that A is equals to U by M multiplied by dm by dt minus of g. Yes, let's just replace the value. That acceleration required, that is of 20 meter per second square, this is 20 multiplied by initial speed, it's an 800, mass of the rocket which is a 5000 multiplied by dm by dt minus of 10. So this would be 30 is equals to, this would be gone. Yes, so this is 30 is equals to 8 by 50 into dm by dt, and if I replace the value and dm by dt, it's a 50 into 30, that's 1500 divide by 8. If I solve this, it would be a 187.5 kg per second. This would be the answer. I hope these things are clear. Is it clear? Any doubts? Any confusion? No? Great. So can you do this kind of question? Can you? Are you sure? Great. Let's look at one of the MCQ. It says the propulsion of rocket is based on the principle of law of conservation of, yes, it bases on the law of conservation of linear momentum. Yes, theoretical question, but very important to remember this. Yes, okay. So shall we move to the numericals? Shall we? Let's have a look. Suppose it says that a rocket system is having total mass of 2000 kg, in which 1500 plus 500, this is the system, this is the fuel tank. If it is moving with a speed of 10,000 meter per second, find out acceleration of the system t is equals to 10 seconds, if dm by dt is 10 kg per second. Yes, go through the data one more time. Go through the data. What does it say? It says that a rocket system is there and it is having a total mass of 2000 kg, in which 2000 kg 1500 kg would be of system and 500 kg would be of fuel tank. If it is moving with a speed of 10,000 meter per second, find out acceleration of the system at t is equals to 10 seconds, and they have provided that dm by dt, that would be equals to a 10 kg per second. So now what can we do? What is the options? Yes, I want an acceleration. Acceleration can be written as it's a v dm by dt divided by m naught, which was the initial mass, minus of dm by dt multiplied by t minus of g. Yes, the velocity is 10,000 meter per second, that is 10 into 10 to the power 3 multiplied by dm by dt, which is a 10 kg per second. So again 10 divided by m naught, which is an initial mass, it's a 2000, minus of dm by dt, which is a 10 kg per second minus of 10 seconds. So this is 10 into 10 minus 10. This is the acceleration. So this is 10 into 10 into 10, it's a 10 to the power 5 divide by 2000 minus of 100, so this would be 1900 minus of 10. I hope these things are clear. So this could be written as this is 10 to the power 3 multiplied by 10 square divided by this is 1900 minus of 10. So here 10 square, here 19 has been gone, 1000 divided by 19 minus of 10. Yes, it's 1000 divided by 19 minus of 10. So when I solve this, it's 1000 divided by 19. What it would be? 1000 divided by 19. Yes, what it would be? It's an so it's a 19 6 104 and 19 5 it's a 95. Approximately it was 5.5 minus of 10. This is equals to minus of 4.5 meter per second square. Minus is there because the g is acting in the downward direction. And acceleration of the rocket, or we can say acceleration of the system, is in positive x direction, positive y direction. I'm sorry. I hope these things are clear. Is it clear? Any doubts? Anything? No? Great. Let's look at the next question and next situation. Let's suppose a balloon of mass 10 gram, this is with air, is moving in upward direction with a speed of 20 meter per second. If dm by dt is 1 gram per second, find out acceleration of balloon at t is equals to 5 seconds. As well as one more information they have provided, that ignore the effect of gravity. They said that ignore the effect of gravity. So how could you do this? Let's summarize the data. they have given the balloon of mass 10 gram, and this 10 gram is considered when I assume it's a balloon plus air filled within it. It's a balloon of mass 10 gram is moving in upward direction with a speed of 20 meter per second. If dm by dt is 1 gram per second, find out the acceleration of the balloon at t is equals to 5 seconds. And while doing this I'm going to ignore the effect of gravity. So let's just begin. It's an a is equals to v dm by dt upon m naught minus of dm by dt into t. So this velocity, the velocity is 20 meter per second, and dm by dt it's a 1 gram per second. So this is 1 divide by m naught, it's a 10 gram minus of dm by dt, it's a 1 gram per second multiplied by 5. So this is 1 into 5. That should be is equals to, this should be equals to 20 divided by 10 minus 5, it's a 5. So this is equals to 4 meter per second square. I hope these things are clear. Is it clear? So this is the acceleration of the balloon. This is the acceleration of the balloon. Is it clear? Is it? Are you sure? So will you be able to solve this kind of question? Will you be? Yes. Let's look at the new questions. Let's suppose they have given that water is coming out from the pipe having length L and cross-sectional area of A. Water is coming out from the pipe having length L and cross-sectional area A with velocity V. If it has been struck to the wall horizontally, find out force acting on the wall. So this is the requirement. Go through the data once. What does it say? It is saying that water is coming out from the pipe having length L and the cross-sectional area is given with velocity V is given. If it has been struck to the wall horizontally, that means let's assume that here it would be the wall and here the pipe would be there. The cross-sectional area of this pipe is A, length would be the L, and water is coming out something like this with speed V. You need to find out the force acting on the wall. Now how could you do this? As you understand that my velocity remains the constant, only the mass that has been struck on the wall would be changing. So what I can write, it's an F that should be is equals to V into dm by dt. Is it clear? Is it? Great. So this is V multiplied by d by dt of mass. How could I write this? On the back of the mind, I must calculate this, that density can be written as mass by volume, and so mass can be written as density into volume. So this is equals to density. This is, that should be is equals to density multiplied by volume. So this is equals to rho multiplied by V multiplied by d by dt of volume. Volume is area into length. So that could be rho into V multiplied by area into dl by dt. Now TL by dt can be written as V. So this is equals to rho V square A, or I should write it's a rho into A into V square. Is it clear? This is very important formula that has been used at various questions, that can be used for various questions. So please do remember this F is equals to rho into A into V square. And many a times a certain questions has been asked from this situation, that something like that in the previous question. Initially, force of 15 Newton is acting on the wall when flow of river or flow of water, sorry, when flow of water is V meter per second. Now if flow of water is doubled, but cross sectional area of pipe is half, cross sectional area of the pipe is half, then find new force. Go through the data very carefully. Go through the data very carefully. What is all about? It's in the previous question, initially force was 50 Newton. When the flow of water is V meter per second, but now if flow of water is doubled and cross sectional area of pipe is half, then find the new force. So what I understand is that my formula was the F is equals to density into cross sectional area multiplied by V square. So what I understand that is the F directly proportional to the A into V square. This is the cross sectional area, but here they are not talking about the cross sectional area. Yes, they are talking about the cross sectional area itself, so it would be an easier. Even they can talk about the radius, or they can talk about the diameter of the pipe, and the things would be quite typical. So let's begin then, that F2 by F1 should be is equals to A2 multiplied by V2 square divided by A1 multiplied by V1 square. So the A2, the new cross sectional area, would be the half, it's an A1 by 2 multiplied by V2. The new velocity would be double, so it's a 4 into V1 square divided by A1 into V1 square. So this V1 square has gone, this gone, this is 2 2s. So F2 should be is equals to 50 into 2, which could be written as 100 into Newton. It's 100 Newton. I hope those things are clear. Is it clear? Any doubts? Any doubts in this? No? Great. So ready for the next question? Are you? Are you ready for the next question? So let's have a look then. Let's suppose, have you seen the garbage collector? Yes, it's a garbage collecting van would be there, and let's suppose a mass of this van, it's an 100 kg, and it is moving with a speed of 20 meter per second, and each one you are going to drop this garbage into this, and each this garbage would be of 500 gram. I hope these things are clear. So if you are dropping garbage of 500 gram per second. Find out force required to be applied on the shown when so that it can move with speed of 20 meter per second. Yes, this is the requirement initially. So what you need to do is you understand that your mass is going to be changed every time. Yes, and this is the moving with the 20 meter per second. So what you need to do is that F should be is equals to V multiplied by dm by dt. My velocity, it would be at 20. My dm, it's 500 gram. So this is 500 divided by 1000, because it says it's a 500 gram per second. So this has gone, and you need to apply a force of 10 Newton. You need to apply a force of 10 Newton continuously from the outside the system. That means you need to probably pull the system, or you need to push the system, sorry, from here, and so that it can continue moving with a speed of 20 meter per second. Is it clear? Is it any doubts? Is there any doubts? No? Okay, so shall I continue with this question and have one more question based on this only? That in the previous question, find out acceleration of when after t is equals to 10 seconds, let's say. So what we were used to do is that acceleration was v into dm by dt divided by mass m. And when the situation was of space shuttle, or situation was of the balloon where mass is going to be decreased, we used to have this relation. This is v dm by dt divided by m naught as an initial mass and minus of dm by dt into t. Yes, this was the system. But why this is minus? Because in that situation the mass of the system is keep decreasing on each second, every second. In this case, let's suppose this is the when, and you are going to add the garbage. To this when. So its mass is not decreasing, it is increasing. And as you can see, it is moving in the horizontal direction. So no need to consider the effect of gravity, or no need to write plus g or minus g. Is it clear? So let's have the value. Acceleration should be equals to v. It should be moving with 20 meter per second. dm by dt, what was it? It's a 500 gram per second. So this is 500 divided by 1000 divide by total mass. It's an m naught initial mass. It's a mass of the van, which is 100 kg, plus dm by dt, that is of 500 divided by 1000 multiplied by how many seconds? It's a 10 seconds. So let's just try to get it done. It's a 10102020, that has been gone. It's a 000000. So this is 2 5s are 10. Divide by this has been completely vanished, and this is 105. Yes, meter per second square. I hope those things are clear. Is it clear? Is it? So will you be able to solve this kind of questions? Will you be able to solve this kind of questions? Are you sure? Can it be done? Can it be? Great. So shall we move to the next concepts? Shall we? Okay, let's have a look. These are the miscellaneous concepts. Yes. So let's have a look. First, I'm going to finding the true weight from a faulty balance. It is the situation. It is the situation when you are using a balance system. That means you are going to use a system like this. That this is the container, and you are at one side. At one side, you are going to put an object whose mass is required, or technically whose weight is required, and on the another end, let's suppose this is the pen. This is the pen where object has been placed, and this is the place where I'm going to put my standard weighing machines, standard weights, so that I can measure it with this standard weights, and I can get it know that this object is of this much weight. So when this balance is faulty, how to get it done? That is what I require. So let's suppose that if the pens are unequal, pens are the unequal, but the arms, this is what we call as, and these are the arms of the machine, but the arms are of equal length. So let's just define the symbols. That W, it's a true weight of the body. A is the length of the each arm, and S and S dash, S and S dash are the weights of the left and right palms. So what you are supposed to do is that place the body in the left pen and let a weight W1 will be placed in the right pen, be required to balance it. Yes, you have put certain object on the left pen, and on the right hand side you have put certain object to balance it. So if I can balance it, I can write like this. It's a W plus S into A. That should be equals to W1 plus S dash into A. So if I try to solve this, because it says that arms are of equal length, so this A and this A has gone. This is W plus S is equals to W1 plus S dash. It is quite possible that you might not knowing that what the A is and why I am doing this. Technically I am just writing the form of the torque over here. You might have gone through the torque, what is torque and all that stuff in the schools. If you are not aware of this, just don't worry, have a focus on this. And when we are going to discuss about the 7th unit, it's a system of particles and rotational motion, we are going to cover the torque. So if you know this, well done. If you don't know, just don't bother, we are going to discuss it in the near future. So let's now let's place the body in the right pen and let W be the weight required to the place in the left pen to balance the body. Now I have changed the object and the weighing machine's pens. Yes, that means I have changed the places of them. Now what you are supposed to do is W2 plus S into A should be equals to W plus S dash into A. This 2, this A has gone, and it's a W2 plus S would be equals to W plus S dash. Yes, replacing the value from the relation number 1, and if I solve this, it's a W is equals to W1 plus W2 by 2. But this is the case when arms are of equal length. If arms are of equal length, then only then I can use this. If arms are not of equal length, what would be the situation? What do you think? Let's have a look. This is the second situation. If the arms are of unequal, but the beam is horizontal when the pens are empty. Yes, initially beams was not horizontal, but arms were equal. Now in this situation, arms are unequal. My arms are the unequal, but my beam is horizontal when the pens are empty. Let's suppose, write it down. It's an A and B. Be the length of the left and right arms. Something like this. That the situation is. So if you observe this situation, one of them is A, another is the B, but both are of unequal length. Both are of unequal length. So as the beam is horizontal, what I can have, it's an SA is equals to S dash B. So for first weighing I can write it's a W plus S into A should be equals to W1 plus S dash into B. And the same way, and on the same way for the second weighing I can have it's a W2 plus S into A should be equals to W plus S dash into B. And if I subtract it and try to get it done, yes, what I can have, it's a W is equals to under root of W1 into W2. You need to remember this relation, but this can be applied if arms are of if arms are of unequal lengths. This is required to calculate true weight. It's a W is equals to under root of W1 into W2. Is it clear? Is it? So if the situation is arms are of equal length, then I can write it's a W is equals to W1 plus W2 divided by 2. And when arms are of unequal length, then W could be calculated, it's a true weight can be calculated as a root of W1 into W2. So is it clear? Is it? Any doubts? Any issue in this? Is there anything? No? Okay, great. Now let's look at the certain question behind this. That let's suppose if my pen machine is faulty and if I have taken observation of one weight, it is 20 kg, or I should write it in the newtons. It is 20 Newton by first method and 45 Newton by second method. Find out true weight. Find out true weight in both the cases. Both the cases means, as a first case, when arms are equal, and second, when arms are unequal. Yes, so have you written it? Did you written it? If not, then just have a look. When arms are of unequal length, please now note it down. Please note it down. If arms are of unequal length, then I can write it's a W is equals to root of W1 into W2. And if I have been given that arms are of equal length, this arms are of equal length, then I can write it's a W is equals to W1 plus W2 by 2. So let's just calculate that arms are of equal length when arms are of equal length, and in second case it's arms are of unequal length. So in first case it's a W is equals to W1 plus W2 by 2. In one method it was the In one method it was the 20 Newton, in second method it would be a 45 Newton. So this is 20 plus 45 by 2. This is 65 by 2, which should be 32.5 Newton. And on a second, when arms are of unequal length, if it was the case, then I can write it's a W is equals to root of W1 into W2. Thus could be written as 20 into 45. And when I write it's a 20 into 45, this is 45 into 20, it's a 900. And under root of 900 would be the 30 Newton. So this two are the cases. But you must remember that when to put which formula, because this is essential. This is very, very essential. I hope these things are clear. Is it clear? So can you do this kind of questions? Can you? Are you sure? Great. So can I just switch to the new concept? Can I? Let's have a look. It's an equilibrium of a particle. Now the first thing, what is equilibrium? Yes, you might even study this equilibrium in class 9, probably in class 10 as well, and now it's in class 11. What do you understand by equilibrium? Let's have an answer. We say that equilibrium of a particle in mechanics refers to the situation when the net external force on the particle is zero. So if net external force that is acting on the system or on a particle is zero, then the particle is said to be in an equilibrium. Now according to the first law, the above statement means that the particle must be at rest or in uniform motion. That means it would be either or in situation, that either it would be at rest or it would be moving with the uniform motion. Now let's just check it out, the different cases, that what could be the situation so that particle could be at rest or particle is moving with certain constant speed. Let's suppose two forces are there, F1 and F2, and these two forces are acting on a particle. Then the condition for the equilibrium is that what I want that the resulting effect of this two should be a zero. So what I can write, it's an F1 plus F2 is equals to 0, or I can have it's an F1 is equals to minus of F2. So if one of the force is acting in positive x direction, another force must be acting in negative direction, and this two forces on the particle must be equal and opposite. That is the only situation where two forces can create a zero resulting force, or I should say its particle would be at rest. Is it clear? Is it? So this is the situation. When only two forces are there. Now let's suppose if more than two forces are there, and these forces are acting on the certain particle, what would be the situation? Let's have a look. If two or more forces act such that their lines of action passes through a common point, they are called as a concurrent forces. Yes, these are the concurrent forces. So equilibrium under these three concurrent forces is F1, F2, F3, requires that their vector addition would be equals to 0. Yes, so if the vector addition of this forces is 0, so we can have it's an F1 plus F2 plus F3, that would be equals to 0. Ideally I should write it as a null vector that we have discussed in the class of the vectors. Yes, this is null vector. So what could be the situation? Let's have a graphical approach of it. That let's suppose this is force 1, this is force 2. If this is force 1, this is force 2, and let's suppose that this is the angle theta between these two vectors, it's an angle between force F1 and F2. So the resultant, let's suppose the resultant of F1 and F2 is in this direction. So if I want that, the resulting effect, that means the net force due to F1, F2 and F3 is 0, then I must arrange the situation such as that Fr and F3 are same in magnitude. Only then and then it is possible that F net or net force of the system is 0. Is it clear? Is it clear? So if I can arrange this, let's have a look. That in other words, the resultant of any two forces, say F1 and F2, obtained by the parallelogram law of forces, must be equal and opposite to the third force, that is of F3. So if I can do this, my particle could be at rest and it would be in equilibrium. If I could not achieve this, my particle or my system is not in the equilibrium. Is it clear? Is it? Yes. So the three forces are in equilibrium, can be represented by the three sides of a triangle, and they can considered in the taken in the same order, so that their summation would be the 0. If it is the case, for the more than three forces, it is something like this, that this first, second, third, fourth and nth. So let's suppose this is F1, this is F2, this is F3, this is F4 and this is, let's say, Fn. So look at this, I have kept the direction of each one, everyone on a same. So if I'm going to add this, it's an F1 plus F2 plus F3 and up to Fn. If I'm going to add this, it would be the 0. Yes, because all the vectors are moving in the same direction. This is what we have discussed in the law of polygon. This is the case when we have discussed, it's a law of polygon. Is it clear? Yes. So we can say it's all the forces in x direction are 0 and all the forces in y direction are 0 and all the forces in z direction are 0. So this is equilibrium is. I hope these things are clear. So do you understand completely what equilibrium is and what should be the values of the force if I want an equilibrium? Do you understand it completely? Yes. Let's have a look to the next questions based on the equilibrium. Let's suppose if this is the force of 5 Newton, find out magnitude and direction of second force, so that F1 shall be, or I should say particle will be, so that particle will be in equilibrium. So what you need to do is that you want that Fr, that should be is equals to vector of F1 plus F2. Let's suppose I am going to apply this vector, it's an F2. What I understand is that in equilibrium the resulting force would be a 0. So this is 0. This is F1 plus F2. So F2 could be written as minus of F1. So if I can arrange this, it's a 5 Newton force in positive x direction. If I am applying this force in this direction having same magnitude, look at this, the magnitude of both the forces are same but their direction are opposite. That's why resulting force, or I can say it's a particle, resulting force on the particle P is 0. Is it clear? Is it clear? Are you sure? Can you do this? Can you? So is it possible for you to calculate this? Are you sure? So will you be able to solve some more questions? Are you? Let's have a look then. Let's suppose it's a one of the force which is of, let's suppose, 3 Newton. This is second force. This is of 4 Newton. Find magnitude and direction of third force, so that here a particle P is there, here the particle P is there, so that particle P can be at rest. So go through this data very carefully. What they say is that a particle is given, and on this particle two forces are being applied, and these two forces are perpendicular to each other. You need to find out the third force. You need to find out the third force so that particle P can be at rest. So what I can do is that let's suppose this is the first situation F1, this is the second situation F2, this is of 3 Newton, this is of 4 Newton. So if I take a resulting effect of this two, I can have it's a 3 Newton, 4 Newton. That means this is Fr should be is equals to 5 Newton, and the angle this is 4, that means this is 4, this should be 5, so this angle should be equals to 53. So even the new vector would be required, that is the F3 would be required. It would be of same magnitude. This F new should be equals to 5 Newton, and it makes an here it's an angle 53, from here it's a 90 degree. So new force should be of 5 Newton, and its angle with 4 Newton force, its angle with 4 Newton force is 90 degree. It's a 90 degree plus 53. It's a 90 plus 53, which is 143 degree. I hope this is clear. Is it clear? So these are the approaches. These are the approaches to find out the equilibrium system. One more approach that we have discussed when we were discussing the vectors, and at that time, if you remember, on a very last we have discussed Lem's theorem. What does it says? It says if particle P is in equilibrium and it has been acted by three forces. Let's suppose this is A, this is B, and this is force C. So this it has been acted by these three forces, force A, force B, force C, and you know the angle between this is alpha, angle between this is beta, and angle between this is gamma. Then if this is particle P, if particle P is in equilibrium, if particle P is in equilibrium, then what we were used to write, it's a force of A divide by, you need to write the angle of sine, or you need to pick that angle of sine that has not been designed from the A, that is the beta. So this is FA divided by sine of beta, that should be is equals to again FB divided by angle of sine that has not been designed by the B, it's in gamma. So this is sine of gamma, Same way, this is f of c divided by sine of alpha, and that's it. So I hope you can understand this. This is fa by sine beta equals to fb by sine of gamma, and that should be is equals to fc by sine of alpha. Is it clear? Is it? Any doubts? Anything? No? Are you sure? Are you sure? So ready for the question? Let's have a look. What does it say? It says that the situation is given something like this, that here one rigid support is there, and from here a string is there, another string is in this direction, and here one of the weight is there. Let's suppose this is of 10 kg, and let's suppose this angle is given, this is of 30 degree. If this is of 30 degree, so what I understand is, let's make a horizontal level. If this is 30, this must be a 30, this must be a 90 degree, this is 30 plus 90, this angle would be of 90. Yes, that can be seen. So this is 30 plus 90, it's a 120, 120 plus 90, it's a 210. So the remaining angle must be 150 degree. Now which forces are acting on them? That this is let's say tension at A, this is tension at B, and this is tension at C. Yes, these three forces are acting. And let's suppose you need to find out tension at A, tension at B, and tension at C. I understand that at this point of time you don't know what tension force is, why I have applied it in that specific direction only, and how could I come to know that in which direction tension should be acting. But at this point of time, your task is to apply Lam's theorem only. That's it. In the next sessions, when we are going to learn about the tension force, then even you will be able to apply the tension force correctly. But until then, you need to just focus on the formula only. This is 10 kg block, so if I calculate its mg, it would be a 10 into 10, which should be 100 Newton. I hope this is clear. So now let's just write it down, the Lam's theorem. And Lam's theorem can be written as, it's a TA divided by sine of 90 degree should be is equals to TB divided by sine of this complete angle needs to be considered. This is 30 plus 90, which is 120 degree. That should be is equals to TC divided by 100. Is it clear? Now TA divided by sine 90 could be written as 1. That should be is equals to, let's just compare this. Let's just compare this with TC. Here I made a mistake, that is of TC divided by here it's a TC, it's a divided by sine of 150 degree. So TC would be of 100 Newton, this is of 100 divided by sine of 150 degree. So this is TA divided by 100 divided by sine 150. What is it? Sine 150 is same as the sine 30. That sine 30 would be equals to half. This is equals to 200 Newton. I hope these things are clear. Is it clear? Yes. So same way you can also have a value of the TB. Let's have a look. It's a TB divided by sine of 120 degree should be is equals to TC divided by sine of 150 degree. So this is TB divided by sine 120, it's a sine 60, and sine 60 can be written as root 3 by 2 should be equals to TC. This is of 100 divided by sine 150, it's a 1 by 2. This 2 can be gone, and this root 3 times of TB should be equals to 100, or I can say it's a TB is equals to 100 sorry, this TB, this TB equals to 100 into root 3 Newton. I hope these things are clear. Even this could be done when this is the case. Is it clear? Is it clear? Are you sure? Are you interested to look one more approach towards this question? Are you? So let's have a look then. It's a second approach to get it done. So let me redraw the structure. The situation is something like this. And here one of the object was there. Yes, this is of 10. So this is 10 into 10, and that would be equals to 100 Newton. This angle is of 30 degree. So it is obvious that even this angle would be of 30 degree. This is TA, this is TB, this is TB, and this would be the TC. Now what can you do? They have already mentioned that this point P is in equilibrium. That means net force acting on it is 0. So let's just resolve this vector into cos and sine component. So what I can have, it's a TA cos 30 in this direction, TA sine 30 degree in this direction, TB is already in this direction, and TC let's suppose in this direction. So what I can have, I know that net amount of force on this is 0. So what I can write, it's a TA cos 30 degree should be equals to TB, and TA sine 30 degree, that should be is equals to 100 Newton. So from this it's a TA into sine 30, it's a 1 by 2 would be equals to 100, and it's a TA that would be equals to 200 Newton. Now once you are having a value of TA, you can easily calculate the value of the TB, yes, which is over here. I hope these things are clear. So will you be able to solve this kind of questions? Are you sure? Great. So let's just wind it up this session over here. Yes, in this session we were discussing about the different miscellaneous concepts. First we were starting with the variable mass system, then we have switched to the weighing machines, and if weighing machine is faulty, how could we find out the actual or the true weight using that weighing machine. And next, a concept of equilibrium and their applications. Yes, so please, as we have discussed in the previous classes as well, this is the heart of the physics. If we have command over it, it would be much easier to understand the next topics and next concepts. So please revise it thoroughly. Do as many questions as possible. Thank you. Have a good day. Take care.